This is Daryl with Cisco Hands-On Training. It's the 23rd of March 2009, and today we're going to go into IOS ACLs. The website is ciscohandsontraining.com, and of course in iTunes you can search on Cisco Podcast. One thing I wanted to bring up from last episode. Last episode we configured NAT on iOS in the router. I do want to warn you that iOS is not the best NAT device on the planet. If you just need to do a small amount of natting for a couple hundred people, you can certainly do it with iOS. But if you're doing NAT for thousands of people at a large site, you really want a device that is designed to do that well. And I remember one instance when I was running a large event with several thousand users on a Cat 6K with a SOUP 2 MSFC2 running NAT. The box was barely able to keep up with it, and the event, while successful, almost failed. What we did the next year is we went and used a firewall service module, which is based on the old PIX software, and the PIX and the firewall service module and the newer replacement ASA, they do NAT very, very well. And in fact, some people say the PIX is a better NAT box than a firewall box. But in any event, if you're doing large capacity NAT, you want to be very careful about doing it in an iOS box. iOS works great for NAT, in small and sometimes medium sites, but don't expect to be able to run an entire large corporation off of an iOS box doing NAT. Okay, that's your warning about NAT. IOS ACLs. An ACL is an access control list on a router, and it's used to restrict traffic. It is stateless on iOS. It's not, the router has no memory of what went out, and so it just knows what the packet is right now. Let's, for today's exercise, here's my map. I'm using the same environment as last time, where I have my router here doing NAT and overloading everything to this fast Ethernet, fast Ethernet's IP address outbound. Let's go ahead, and what we're going to do is we're going to protect the environment, putting ACLs outbound and inbound on this router's uplink. Now I want to use extended access lists for this. There are numbered access lists and named access lists in iOS. The old numbers, here you can do, here's an example where I do, where I'm in config T mode and access list question mark, and you can see access lists 1 through 99 are standard access lists, which are based on the destination, where you can match the destination IP address only. Access lists 100 to 199 are the extended access list, where you can match the source IP address and the destination IP address. And then there's another range for extended access lists up above 2000. And then there are other access list ranges for other types of access lists, like if you want to match based on MAC addresses or protocol, like if you wanted to deny all ARP traffic on an interface, you could use a protocol type access list for that. Generally in production I use extended access lists, and I'm going to recommend that you use named access lists. I've seen a bunch of people use access list 100 or access list 101 in their environment. And the problem is, if you write an access list 101, as a lot of people do, and you deploy it on router X, and it's designed for router X, and then you have another access list 101 on router Y for a different purpose, if you accidentally push the wrong, the access list 101 to the wrong router, then you could cause a major outage. Whereas if you're using a named access list, then if you're using a named access list, even if you push the ACL to the wrong router, there's a very low probability that you end up using the same name on both routers, and that you'll accidentally cause an outage in that circumstance. Okay, so let's go ahead and configure our access lists. And so conft, I'm going to pick a host name for this router, and let's call it sun-isp-gw1. let me, yeah. So I'm running with the naming convention here. Sun refers to the city that it's in. ISP is the function, so it's an ISP gateway, and gateway 1, it's a gateway or a router. And then IP access list extended sun-out. So now what I'm doing is sun-isp-out. What I'm doing here is I'm using a named access list, and I'm basing the name on the router, the name of the access list on the router name. And that way, when you're looking at the list of access lists offline on a server or something, you'll have an idea of which router it's on. And that will decrease the probability of clobbering access list by pushing it on the wrong box. And since the name is unique to the host name of the router, it's very unlikely, even if I pushed it to the wrong router, I wouldn't clobber anything. Those are important considerations. You push the wrong ACL to a router, if it takes effect, like if you used access list 101 on 2 different routers, you push the wrong one, you could cause a revenue impacting outage. Bad idea. Okay, IP access list extended sun-isp-out, deny IP any, and then IP access list extended, actually sun-isp-in, deny IP any log, and now show access list. So you can see I made a mistake in my sun-isp-in access or out access list. I wanted to log it. So another advantage of the named access list is they let you edit the access list. IP access list sun extended sun-isp-out. And actually I don't see line numbers on this access list here, so no deny IP any, deny IP any log, show access list sun-isp-out. Okay. So there's my access list, and it's denying everything and it's logging it. Let's apply it to the interface. Conft int fast 0/1, and then IP access group sun-isp-out IP access group sun-isp-in. And now let's go ahead and look. Let's go ahead and ping that well-known DNS server we were able to successfully ping earlier. And my ping is failing. Let's go ahead and look at my log. And you can see outbound, I'm denying the ICMP packet. So now if I do a show log, not seeing anything in there. Logging. Okay, so I want to set up the logging. So logging buffered notifications. There are different, there are like 7 different severities of logging. Severity 1 is the alerts, like that's something like my power supply failed, I'm going to turn myself off in 3 seconds. And critical conditions, 1 of 2 power supplies failed, you better fix it. and all the way down to debugging, which is I'm forwarding packets the way I'm supposed to normally forward, no big deal. We're going to do logging buffered notifications. Okay. And so now I pinged an IP address, an invalid IP 4.4.4.4. Let me see if it shows up in the log. Nah, not showing up in the log. Well, I can see the console logs at least. Okay, let's go ahead and modify our access lists. And the thing is, we're going to be editing a lot of access lists here. And you can see that just deleting that one line and adding the new line was a real pain in the neck. So what we want to do is we want to actually edit our access lists offline and copy them to the router. And we want to do it in a way that makes it easy to maintain the access lists. So what we want to do is here's a script. It's called ACL VI, and what it does is it uses revision control system to maintain revisions on the ACL. So you type in ACL VI and then the host name of the ACL file on a Unix box, and it'll check it out with locking, and then the $1 is the command line argument, which is the file, the name of the ACL file. And then it'll let you edit it with VI, which is a text editor used by sysadmins commonly. And then it'll check it in and unlock it. So let's create an ACL file, ACL VI, and again, sun-isp -ACL. Oh, let's see, /. I don't have the current directory in my path. So now I'm going to edit the file, and I will put no IP access -list extended sun-isp-in, and then no IP access -list extended sun-isp-out, and I will end at the end, and then I can put in what I want in addition. So let's see. Outbound, I want to allow pings. Permit ICMP any. And inbound, I want to permit ICMP any, and now I can type echo, and then permit ICMP any. Actually, I want to deny ICMP any echo inbound. And I'll log it. So what I'm doing here is inbound, I'm denying people out on the internet pinging me, initiating pings to me, but I'm allowing all other ICMP messages in, like time to live exceeded, an echo reply. And then, meanwhile, outbound, I'm just allowing all ICMP outbound. So I want to be able to make it so I can ping outbound, but other people can't ping me inbound. But if there's other stuff like the time to live exceeded, I'll get those messages as well. And the nice thing about RCS is it asks for a comment. Actually, this is the initial revision. So initial version of home ISP ACL. So now that ACL file is in /private TFTP boot on my Mac, and I am actually running a TFTP server on my Mac. Actually, the Macs have TFTP server built in, but configuring it is a real pain in the neck. So there's a website where somebody posted a utility for easily turning on the TFTP server on the box. And here is the website, and I've used this program successfully, and I thank them for it. So let's go ahead and go to the router. And on the router, let's do a copy TFTP run. So show access-list, and then copy TFTP run, and it asks for the IP address of the remote host. I'll type in the IP address of my Unix box, because the Mac is Unix. And then the file name is sun-isp-acl. Copy it to the running config. It downloads the ACL. My console went unresponsive. Oh, console went unresponsive for a bit, but it came back. And then here is the ACL after I did the copy. And you can see I have my NAT a NAT pool ACL up here that I was using, I'm using. But access list sun ISPN, deny ICMP any echo log, permit ICMP any, deny IP any log, and then here I got the permits. So now let's try to do a ping. And now I can successfully ping out, and I'm getting the response. Okay, so we have our first successful instance here. But now if I try to ping www.cisco.com, it just hangs. Why is it hanging? What is it trying to do? Now I'm not seeing a log message here, but I know that what it's trying to do is it's trying to do a DNS query, and I'm not allowing DNS to work because my ACL only allows ping. So let's go ahead and edit the ACL and allow DNS to work. So I'll /ACL vi sun-isp-ACL. And now I need to write an ACL that allows DNS to work outbound. Now DNS uses port 53, and DNS uses port 53, and it can run over TCP or UDP. Most DNS lookups are over UDP, but if you try to do a DNS lookup for a host with more than 20, or for a host name with more than 20 IP addresses associated with it, then it's also going to use, then it's going to switch over to TCP. So in order for DNS to work properly, you have to allow port 53 TCP and UDP outbound. So let's work on the outbound first. So permit UDP, and then if I wanted, I could set the source IP address to be, the source IP address outbound, which would be the same as in the ACLs, which is 10net. So let me go ahead and do that. Here's some inbound stuff. Permit UDP 10.0.1.0.0.0.255 any equal 53, and permit TCP 10.0.1.0.0.0.255 any equal 53. So I could have said permit any equal 53 because I know that outbound, all the outbound stuff will initiate from my source address range. It is a little bit safer to put in IP address ranges though, because that way if you accidentally apply the ACL in the wrong direction, you will be less likely to compromise your security. It does make the ACLs look more complex though. Now this is outbound, and then I need to allow the response inbound. So inbound, it would be permit UDP any equal 53, and then 10.0.1.0.0.0.0.255, and then greater than 1023. So what's happening here is inbound, I know the source port is going to be 53, but I don't know what the destination port is going to be. The destination port is going to be a random high port. So I could just leave it like this, but then the problem is that if there's a hostile attacker out there and wanted to attack me, all they have to do is they can get into my network by just sourcing UDP packets with the source port of 53, and that's a common thing that hackers do. So I want to try to minimize that risk, and one way to minimize that risk is not allowing them to get to the low-numbered ports. So I will only allow them to get to the high-numbered ports. And then for TCP, I need to let them back in, but TCP has some state, so I can use that to my advantage here. So permit TCP any equal 53, 10.0.1.0, 0.0.0.0.255. Now I could say greater than 1023. Let me say established. So I will only allow TCP responses in that are established. TCP maintains state. Once you initially create the socket, and then once you create the socket, all of the following TCP packets, TCP segments have an established flag in them. So that way, I won't allow people outside to initiate TCP connections in, but I'll allow them to continue to talk on existing connections. And now I have a revision control message that I type in, and this is another advantage of using revision control. Generally in a production environment, you're going to get audited. You're going to have to be able to prove that all of your firewall holes or ACL holes are approved by security, and you have appropriate firewall controls. So you can put in change requests 327 working, and then DNS that works is useful. And now if I do an rlog sun-isp-ACL, I can see that I have 2 revisions of the ACL file, and I have the initial revision, and then I have the next one where I have my change request number documented, and it says that DNS works is useful. And if I want to see what changes I introduced, I could do rcs-diff -r1.2-r1.1 sun-isp-ACL, and it can tell me that in revision 1.2 I added these 4 lines, and it gives me the line numbers. So you can see how having stuff under revision control is useful. I can add all of these comments about what it is. I know what changed and when. If I make a change and something stops working, then I can, with a few extra revision control commands that most programmers will know, I can revert back to revision 1.1 and recover from the outage. Okay, so I've updated my ACL file. Let's push it to the router. Copy TFTP run, and then it auto-filled it out with the IP address, it auto-filled it out with the ACL name, change it to running config, it downloads the ACL, it puts it in place. The router thinks about it for a little while because this is an old, slow router. In fact, it thinks about it for so long, I'm going to pause it for a bit. And we're back. Show access-list. And there's my new access list. Show run pipe include access-group. And hopefully I can ping host www.cisco.com, and I can do a DNS lookup on www.cisco.com. Now I could ping that other IP address. Well, we already tested that I can ping. Now I know that DNS is working. Great. Now let me try to refresh this website. Not working. Why is it not working? Well, it's not working because my ACLs don't permit any web traffic at all. So let's go fix my ACL. So host www.2.unime.it. And here's the host IP address. So let's say I want to enable it so I can get to this particular web server. Not very smart, but let's do that anyway. So /ACL-vi. You always get in the habit of editing your ACL files with your revision control thing. If you edit the ACL files without using revision control, then the next time you use revision control, you'll blow away your file. Although generally the revision control will keep the permissions in such a way that you can't blow it away. But now let's see, outbound, I want to be able to connect to that host. So permit TCP 10.0.1.0, 0.0.0.255, host, oops, what was that host name? Hosts 192.167.101.93 equal 80. Ah! Okay, I made a mistake with VI. Wow, I made a lot of mistakes with VI. Okay, what I'm going to do here is I'm going to hit Escape, Control Q to edit out a VI without any edits, and then I'm going to try it again. Permit TCP 10.0.1.0, 0.0.0.255, host 192.167.101.93 equal, and then it's web, so it's port 80. Port 80, and then I need a permit TCP established for the other direction, and you know, it's going to get real tiring creating a bunch of TCP established for all this stuff. So instead, near the top of my ACL, I could put permit TCP any established. Or permit TCP any, and then 10.0.1.0, 0.0.0.255 established. And that way I don't need to worry about specific established anymore. And let's see, now I need a comment and making TCP more manageable with permit TCP any established. Let's do an RCS diff, -r 1.2. So the old version was 1.2. I created 1.3. And you can see I deleted this, I created this new TCP established line for everything. I eliminated the old TCP established line specific to DNS, and then I created my new line to allow outbound web, allow outbound to access the web on that specific remote host at that specific port. Let's push my ACL to the router. And then show access lists. And let's see if this gets a little bit better now. I'll hit shift refresh. And you can see now this web server is working. But maybe this is cached from earlier. Let me go to a website I haven't gone to recently. www.abcnews.com I have not gone to recently. So, okay, seems my web browser was smart enough to do cached stuff. And then okay, so my web browser did some cache stuff, and but I'm sorry, there's one remote website that I can get to right now, but I can't get to any other websites. So let's fix that, because generally you want to be able to web surf from home, right? So ACL edit, ACL, or I'm sorry, /ACL vi sun-isp-ACL, and then instead of permitting TCP outbound to this specific host, let's allow TCP outbound to, let's do something wacky here. Let's allow it outbound to all even numbered IP addresses on the internet. Now these are don't care bits, so let's say we'll permit it to 0.0.0, we'll permit it to 0.0.0.0, 0.0.0. Oh, and don't care bits, we don't care about 255.255.255.254. Okay, this is an incredibly silly thing to do, but what I'm doing here is I'm saying I don't care about the first 31 bits of any IP address that I go to. I'm going to allow it on port 80, and then on the last bit I do care about. So the last bit has to be a 0. Now the only reason I'm doing this is because I want to make sure that you understand that these are don't care bits at the end. And the don't care bits don't have to be contiguous. It's a bad idea to make it non-contiguous, but you know, there are plenty of bad things you can do with the right tools, and this is just one of them. So let's go ahead and do that. So this will allow me to access half the internet, and the half of the internet will be internets with IP addresses ending with even numbers. Allow access to internet IPs with ending with bit 0. Okay. Now let's go ahead and find some websites. www.abcnews.com does not seem to be working. Oh, I'm sorry, I just edited the file. It'd be nice if I actually pushed the ACL file. And here's the access list. And you can see how wrong this looks. These are the way don't care bits are supposed to look in iOS ACLs. You're supposed to have zeros in the front and 255s at the back, or something like that, and bits at the back. In this one, this is backwards. This looks like a netmask, but in iOS ACLs, it's not netmask, so it's don't care bits. In fact, one of the worst errors you can make in an iOS ACL is to accidentally deploy a netmask. In any event, at this point, I should be able to get to half the internet on port 80. Let's try a couple of websites. Okay, I can't. Seems like I can't get to www.abcnews.com. Okay, so I can get to ciscohandsontraining.com, and ciscohandsontraining.com does have an IP address that is even, but if I went to www.cisco.com and I hit the refresh button, if I hit refresh, it fails. And www.cisco.com has an odd IP address. So you can see I've accomplished something rather silly here. And here you can see a bunch of log messages. Here you can see here are a whole bunch of websites that I've been denying since I pushed that. And you can see they're all odd. .49, .191, .123. So all the .25, this is Cisco, www.cisco.com's IP address. So you can see with that ACL, I managed to deny all web traffic to all IP addresses which are odd out on the internet. So, okay, well that was a silly thing to do. Let's go ahead and fix our ACL. /ACL vi sun-isp-ACL. And we certainly want to be able to access the whole internet on port 80. So I will allow that.
and permit TCP 10.0.1.0, 0.0.0.255, any equal 443, because 443 is often used for web traffic. And here is, okay, that's pretty good. Fixing internet web surfing. My comments. Notice when you leave the comment in revision control, a dot on a line by itself ends the comment. Let's push the ACL to the router. Show access list. And so you can see now we can access anything on dub-to-dub or anything on port 443. Dub-to-dub is port 80. Domain is 53. So let's go see if things are a little bit better. And you can see now I can get to cisco.com and it's all working. Although you're going to find, you know, there's 65,000 ports out there, 65,532 TCP ports, 65,532 UDP ports. I'm currently allowing 1 UDP port out and 3 TCP ports out, and that's it. So you're going to find a lot of applications are not going to work. Like if I tried to VPN into work right now, VPN uses a different port, VPN would fail. Okay, I think that's it for access lists for today, but you know, let's yeah, I think that's it for access lists today. I just want to make sure, I just want to review real quick the don't care bits. If I got an IP address 10.1.2.3, let's say I've got permit TCP any 10.1.3.2 0.0.0.1. So I'm permitting TCP from any source IP to a set of destination IPs. And what is in the set? Well, it has to match this IP address here, except we don't care about, in this case, the last bit. So the IP address is 10, so that is, you know, since we care about the first 3 octets, it's 10 to, what did I do? 0.0.0.1. Since we care about the first 3 octets, or since we care about all the bits in the first 3 octets, we know that it starts with 10.1.3. And the question is, what is allowed in the last octet? So 2 is in binary 00000010, because this is the 2's bit. And our don't care bits are, so 2 is, and then don't care is 00000001. So we need it to match this, except we don't care about the last bit. So that gives us 2 options. 00000010 and 00000011. See, we don't care about the last bit. So this and this all match this, except for the last bit, which we don't care about because of our don't care bit. So this is 2, and this is 3. So the original permit TCP any this matches 10.1.3.2 and 10.1.3.3. Let's do another more complicated example. Permit TCP any 10.1.3.64 0.0.0.31. Okay? We know the first 3 octets. We care about all the bits, so we know that the IP address starts with 10.1.3. 64 in binary is 128, 64, 32, 16, 8, 4, 2, 1. This is 64 in binary. Don't care bits of 31. So that is don't care, and then 128, 64, 32, 16. So 31 is 16 plus 8 plus 4 plus 2 plus 1. Okay, so the 64 in binary is 0, 1, 0, 0, 0, 0, 0, 0. The 31 don't care bits are 0, 0, 0, 1, 1, 1, 1, 1. And that means that the highest IP that we can match is 0, 1, 0, 1, 1, 1, 1, 1. And the lowest IP is 0, 1, 0, 0, 0, 0, 0. Is that 8 bits there? Yeah. So the highest IP is, we've got 64 plus 64 not plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that is 95. And the lowest IP is obviously what we started with, is in this case what we started with, which is 64. So this line here matches 10.1.3.64 through 10.1.3.95. Now these are all contiguous bits so far. We can do wacky things. So permit TCP any 10.1.3.64 0.0.0.6. Now this is wacky. And the reason it's wacky is because our don't care bits are discontiguous. And you don't want to do this in production. You want to avoid don't care bits. You want to avoid don't care bits that are non-contiguous, because while it's sort of a fancy thing to do, and sometimes it can be useful for you, it's just going to cause confusion down the line. When I interview people, I regularly ask them to do a discontiguous don't care bit example, just to see if they can do it. And I've sadly, frankly, I'm very sad I have not actually had anybody successfully answer questions like this before. Okay, in any event, 10.1.3.64, we know we care about the first 3 octets, 10.1.3, and then for the last octet, 64 is 0, 1, 0, 0, 0, 0, 0, 0, and then the don't care bits of 6 don't care is 0, 0, 0, 0, 0, 0, or 0, 1, 1, 0. 2 plus 4. So what that means is that we've got 2 bits that we don't care about, so we have 4 possible answers. Busy around here. Okay, so the don't care bits, so that means we have 4 possible combinations. So here are the 4 possible combinations, and these bits, they can be 0, 0, or they can be 0, 1, or they can be 1, 0, or they can be 1, 1. So the answer is that this instance here matches 10.1.3.64, which is this one, or 10.1.3.66, or which is this one, or 10.1.3
1.3.68, which is this one, or 10.1.3.70, which is this one. So you can see this is not very intuitive. Discontiguous don't care bits are very, very bad and you don't want them. It just makes things complicated. You can try to make it fancy. If you ever take a CCIE lab, they will probably ask you a question to write an ACL in the fewest number of lines possible, and you will be forced to write them in discontiguous bits if you want to get the question correct, but you never want to do that in production. You want ACLs that are easy and simple to understand. Let's take one last look at the ACL file. Show access list. Oh, I'm sorry, there's one other horrible mistake you can make dealing with ACLs that I want to warn you about. Firewalls, the FWSM, the PIXes, the ASAs, they use netmask format. They'll use permit TCP any 10.1.2.0. They'll use a netmask. This is a this would be like a PIX or an ASA ACL. Whereas an iOS ACL uses don't care bits, permit TCP any 10.1.2.0, 0.0.0.255. Now, if you accidentally write an ACL in PIX format and push it to an iOS box, it's still valid syntax. But because the don't care bits are not what you expect, you could make a horrible mistake. Let's say you wanted to allow the internet to access a border zone net on port 80. So this is what you want. You want to allow the internet to access a border zone net on port 80, but you accidentally write this. Then what you're doing is you're allowing anything out on the internet to access any IP address inside your company that ends with the last octet of 0 on port 80. So you've made a bad mistake and you've generated a security vulnerability for the company. So it is, frankly, I prefer writing ACLs on the PIXes and the ASAs because they don't allow you to use discontiguous bits. They only allow you to use netmasks, but you must be absolutely certain never to accidentally write something in netmask format and push it to an iOS router. And that's something you want to be very careful about when reviewing ACLs. You want to understand exactly what device the ACL is getting pushed to and whether the device uses a netmask or don't care bit format, and you never want to push a netmask ACL to a don't care bit iOS device. Okay, that concludes today's class on access lists.